Over the last century, we have managed to map the observable universe to an astonishing degree of precision. Nearly a century ago, we recognized that distant galaxies are systematically shifting to the red end of the light spectrum. This redshift proved that the cosmos is expanding. Later, we detected a faint hum of microwave radiation coming from all directions. This cosmic microwave background is the physical afterglow of a highly compressed early state. Today, advanced satellites capture that background radiation with remarkable clarity, providing a mathematically rigorous model of the early cosmos. As an observational map, this model works perfectly. But when we run the clock backward to its absolute limit, we make an unproven leap from physics into metaphysics. In reverse, the mathematical model condenses into a hot, incredibly dense state known as the Big Bang. But because equations fail at this extreme density, we mistake a map's boundary for the absolute origin of the territory. To see why this breaks down, we need to understand the function of time. The time we measure, operational time, is really just an internal ordering system for the things we observe. Think of it like the lines of latitude and longitude drawn onto a globe. Time does not flow through the universe like a physical substance, and it isn't a dimension of reality. It is strictly a measuring tool we use to read our specific chart of the cosmos. If time is just a coordinate on our map, the Big Bang cannot be a fiery explosion that created the universe from nothing. It is simply the edge of our chart. Think of a movie theater. You watch a flat screen, but the motion originates from a hidden projector. Under the TCGS-SEQUENTION framework, our three-dimensional universe is that screen. It is a shadow projection cast by the timeless four-dimensional counterspace, a complete, static geometry where nothing moves. Our experience of time passing is merely the projection scheme, a foliation index that flips through individual cross-sections of that timeless whole. Time is the sequence of the frames, not the film itself. Rewinding the projection back to frame 0, we hit the Big Bang. Reaching this first frame doesn't mean the film reel was just manufactured. It simply means our specific projection angle has reached a point where the picture becomes unreadable. The historical timeline of the cosmos is a byproduct of how this projection process works. The underlying higher dimensional reality is already complete, meaning it never actually began. What do we do with astronomical data? We sort it into two categories. First, foliation artifacts. Phenomena like cosmic acceleration may just be optical projection distortions. Second, invariants. The microwave background and light elements are strict mathematical rules of the shadow, not explosive relics. Many cosmologists rely on theories like inflation to explain the early universe, but inflation simply patches holes in a standard timeline. It assumes time is real and tries to make the sequence of events fit the data. Bouncing or cyclic models try to avoid a hard beginning by imagining a universe that simply expands and contracts endlessly. Yet they still trap reality in a constant flow of time. These alternative models spend all their energy arguing about the events unfolding on the movie screen. The TCGS framework looks away from the screen and acknowledges the projector. In the standard model, equations for the early universe hit infinite density and completely break down. This chart singularity tells us our three-dimensional shadow map has lost resolution. The math fails at the limit of legibility, not because the source suddenly began. Think of an ancient maritime map. At the edges of the known ocean, the grid lines dissolve into blank space. The ocean doesn't physically end there. The cartographer's tools simply stopped working. The mathematical breakdown at the Big Bang operates the same way. It points to the structural edge of our shadow reality, rather than a moment of genesis. We don't have to discard our astronomical measurements. The redshift of galaxies, the microwave background, and early element distributions remain perfectly valid constraints. We only discard the assumption that reality started at the beginning of our clock. Cosmology needs to shift away from origin mythology. Instead of hunting for the explosive birth of the universe, we should focus on invariant cartography, mapping the stable, geometric rules of the shadow we live inside. When our most powerful telescopes stare into the deepest regions of space, they are not looking back in time to the absolute moment of creation. The Big Bang is simply the beautiful, unreadable edge of our own